Hello everyone. The type of reaction that we will be performing today is a synthesis reaction. A synthesis reaction combines two or more elements to create a new one, so the main indicator of a synthesis reaction is having one product on the right side of a chemical equation as a result of combining two or more reactants. For example, here's the balanced equation for the reaction we will be conducting in just a few moments. I encourage you to write this down because it will allow you to better understand the reaction as we conduct it. We're not going to spend too much time on this now, but we will come back to it later after the reaction is done. All you need to know for now is that it satisfies the definition for a synthesis reaction. Here we have two reactants, magnesium solid and oxygen gas, and here we have one product, magnesium oxide, which is solid.
First we will take a balance from the instrument shelf and place it on the workbench. Next we will grab a crucible from the container shelf and place it on the balance, and we will record the mass of the crucible. In this case is 88 grams. We will then remove the crucible from the balance and add 5 grams of magnesium to the crucible from the material shelf. We will then place the crucible on the balance and record the total mass of the crucible and magnesium. In this case it is 93 grams. Then we will remove the crucible from the balance and grab a Bunsen burner from the instruments shelf and place it on the workbench. We will place the crucible over the Bunsen burner at a low flame, and we will wait 1 to 2 minutes to allow the reaction to take place. We need a Bunsen burner to provide heat because in order for the reaction to start, we need activation energy. Activation energy is the minimum energy needed for a chemical system with potential reactants to result in a chemical reaction. The magnesium here is burning with oxygen found in the air. If you notice, the lid of the crucible is slightly open, which allows this interaction to take place. This is an exothermic reaction, which I will explain shortly. Let's have a closer look at this reaction. Did you see that? We can tell that magnesium combined with oxygen to form magnesium oxide because of that color change from dark gray to white. So now, for time-saving purposes, I will fast forward through the remaining minute or so of heating. Now we will allow the crucible to cool for 1 to 2 minutes. In the meantime, let's talk about exothermic reactions. So, as I said before, the type of reaction which occurred is an exothermic reaction. This means that heat was released. In exothermic reactions, the energy stored in the molecules, specifically the bonds, is very high. In endothermic reactions, the energy stored is very low. Here's the activation energy, by the way, as you can see on this graph. Now, consider the diatomic oxygen molecule which contains a double covalent bond. This is a stable configuration, which means that the energy stored is very high, and those bonds will be breaking in this reaction to form new ones, in this case an ionic bond between oxygen and magnesium. In this reaction, a magnesium atom gave 2 electrons to the oxygen atom, which wanted to gain 2 electrons to become stable. Alright, back to our crucible. At a minute and a half, we have completed cooling, and we are going to place it on the balance once again. The balance reads 96.289 grams, and the crucible no longer contains just magnesium solid. It is now magnesium oxide, because the magnesium solid and the oxygen gas have combined, or synthesized. It has a mass of 8.289 grams, which means 5 grams of magnesium 2 plus ion and 3.289 grams of oxygen 2 minus ion. That being said, it is now time to clean up our workbench and wrap up.
So once again, this is our synthesis reaction. The reason why we see 2 as a coefficient on magnesium and magnesium oxide is because the oxygen molecule is diatomic, and so we are simply balancing the equation.